Let's start a few more word problems from section 6.4. And for question number 10, Jerry has 80 coins made up of dimes and quarters. And the total value of his coins is $15.20. And I want to know how many dimes and quarters does Jerry have. So I have gone already and I have written out two let statements where D is the number of dimes and Q is the number of quarters. So let's go ahead and figure out how can I write my first equation. Well, I'm given 80 coins, right? So I'm given 80 coins. So the number of coins is 80. So that is made up of the number of dimes plus the number of quarters. So my first equation is D plus Q equals to 80. And remember, D is the number of dimes and Q is the number of quarters. So number plus number gives you the number of quarters, the number of coins, right? So number of dimes plus number of quarters should give you the total number of coins. So that's my first equation. I'm also given a numerical value of $15.20. So the next part is, how do I write an equation with that $15.20? Well, let me put down $15.20 over here in the corner. And hopefully you'll understand that $15.20, I mean, that's just like a money value, right? And dimes has a value of 0.1 and quarters has a value of 0.25. So one mistake that I do see students writing out when they write out their next equation is some students might just say, okay, so they might say 0.1 plus 0.25 equals to, plus 0.25 equals to 1520. So that's kind of right because, you know, they do have like, this is their money value, this is their money value, right? But they're missing the number of coins as well. So what we need to do to fix this is that we need to put a letter D here and the letter Q here. And hopefully that makes sense now because over here, if I have like 6 dimes and if I times that by 10 cents, that would give me 60 cents, right? So that whole expression right there gives me a dollar value. And hopefully this makes sense too because let's just say I have 2 quarters. If I take 2 quarters and multiply that by 25 cents, that would give me 50 cents, right? 50 cents is a money value, right? So now we truly have this expression right here is money, this is money, and this is also going to be money. So that's how you can create your second equation there. Okay, so let me just erase all that. So hopefully you're okay with setting up your 2 equations. Now from here on is just solving by elimination here. Basically what I'm going to do is I'm going to take my first equation right here and I'm going to put that underneath here, but I'm going to times everything here by 0.1. All right, so if I take 0.1 and multiply it with that D, I get 0.1 D. If I take 0.1 and times by Q, I get 0.1 Q. And then if I take 0.1 and times it by 80, so 0.1 times by 80 is going to give me 8, and that'll give me 8 on the right-hand side. So as you can see, what I've done now is I made sure that the coefficients in front of the D variable are the same, and now I can simply go back to what we've been doing a lot in chapter 6 is now solving by elimination, and I will solve by subtracting. Okay, so if I take 0.1D minus 0.1D, the D's will cancel. If I have 0.25Q minus 0.1Q, so that's 25 cents minus 10 cents, that's going to give me 15 cents, so that's 0.15Q. And then finally, if I take 1520 and if I minus 8, 1520 minus 8, that's going to give me $7.20 on the right hand side, and then I can divide both sides by 0.15, divide that by 0.15, and Q would equal to, with my calculator here, this would give me 48 quarters. So I have 48 quarters for that particular problem. All right, now the question is, how many dimes do I have? Well, going back to my first equation, dimes plus quarters equals to 80. So so I have my dimes plus my quarters. Now my quarters is going to be 48, and that's going to equal to 80. And what we need to do now is we need to solve for dimes here by taking the 48 and moving it to the other side. So the number of dimes is going to be 80 minus 48, and that's going to be 32. So I have 32 dimes and 48 quarters for that problem. Okay, let's move on to the next question here. Trisha sells Italian roasted coffee beans for $7.50 per kilogram. That's key, $7.50 per kilogram. And sells French roasted coffee beans for $9 per kilogram. How many kilograms of each roast must she combine to sell a blend of 50 kilograms at $7.98? Okay, so I've gone ahead and I've written out two let statements already. So I will be the number of Italian kilograms of coffee, and F will be the number of French kilograms of coffee. Now, we need to have, for this particular problem, we need 50 kilograms, right? We need a blend. So blend means we're mixing Italian and French coffee. So my very first equation, is going to be I plus F equals to 50. And hopefully that makes sense because 50 is the number of kilograms, and F represents the number of French kilograms of coffee, and I represents the number of Italian kilograms of coffee, right? So kilograms plus kilograms equals to kilograms, right? So that's your first equation. Now the second equation is a little bit more work to do because what we're doing is we're mixing things, and what we're doing is we're trying to make $7.98 per kilogram when we've kind of mixed in the French coffee and the Italian coffee here. Okay, so let's see if we can make an equation here. We know that Italian coffee sells for $7.50 per kilogram. So if it's $7.50 per kilogram, sure, it's $7.50. So here's my $7.50 per kilogram, and I'm going to multiply the $7.50 by I, right? Now, hopefully this makes sense because I is the number of kilograms, and if I times like the number of kilograms by $7.50, that gives me my dollar value, right? So if I have 2 kilograms of Italian coffee, that'll cost me $15. Okay, now how do I make the next expression for the French coffee? Well, French coffee in this particular problem costs $9 per kilograms. So this is going to be $9. And I'm going to multiply that by F. And then finally, now if I follow the units here, I mean, this is like the price, and this is the kilograms, right? So this is the price, and this is the kilograms. So if you think about this logically, this should equal to some kind of price and some kind of kilograms. Okay, well, look at the problem here. I want 50 kilograms at $7.98. All right, so in order to finish that part off, I would need to have the price, which is $7.98, and the number of kilograms is going to be 50. And that's how you can set up your second equation there. Now, I would go ahead and just simplify this. I mean, this is 750I plus $9F. And I would just multiply these two numbers in your calculator, 798. So 798 times by 50 is going to be 399. So that right there is your second equation. Now going back to your first equation, let's go back to this first equation right here. This is we're going to solve this problem by elimination here, and what I'm going to do now is I'm going to multiply the first equation by 750. So let me just erase this now. Now, if I multiply by 750, I can just distribute, right? So 750 times I is going to be 750I. If I do 750 times F, that's going to be 750F. And with your calculator, if I do 750 times 50, that's going to give me 375. So my computer screen is blinking from time to time. All right, so there you go. There is my new system there. There's my system of linear equations here, and I can solve this by subtracting, right? So remember, if I do 750I minus 750I, the I is canceled. If I do $9 of French coffee, subtract 750 of the other French coffee, so 9 minus 750, this is going to be $1.50 F. Oops, 750 F. And on the right hand side, if I do 399 subtract 375, so 399 minus 375, that's going to be 24 over here on the right hand side. And now I can divide both sides by $1.50. So 24 divided by $1.50 is going to be 16. So there's 16 kilograms of French coffee. Okay, and in order to find the number of kilograms of Italian coffee, well, we can go back to our first equation. So I plus F, so F is going to be 16 kilograms. And then we know that equals to 50 in total. So 50 minus 16, 50 minus 16 is going to be 34. So there's going to be 34 kilograms of Italian coffee. And that's how you can solve that one there. Okay, great. Let's keep moving along here. Let's do another one of these combination questions. And for this question, I have a bottle of wine that has 8% alcohol and another bottle that has 15% alcohol. How much of each must be mixed to have 100 liters of 12.2% alcohol wine? Okay, so I've gone ahead and written out two let statements. So L is the number of liters, I guess. So the number of liters of 8% alcohol is X, and the number of liters of 15% alcohol is going to be Y. Okay, so our first equation, let's do it the first one here. We need to have 100 liters, right? So we need to have 100 liters no matter what. All right, so we need liters, right? So that means on the left-hand side, we need liters and liters, right? So our first equation is simply going to be X plus Y equals to 100, right? So X is the number of liters of 8% alcohol and Y is the number of liters of the 15% alcohol. All right, so that's my first equation. Now the second equation, now we're going to start mixing things, right? There's a 12.2% alcohol that we need to combine. However, we're dealing with this 8% alcohol, right? And I don't know how much of that 8% alcohol that we have so far. So what we're going to do is my equation is going to be 0.088%, and then I'm going to times that by the number of liters. Okay, so this is like your percent, and this is your liters. All right. So if you think about that, if you have like 10 liters of this 8% alcohol, that will kind of give you the concentration of the total amount of 8% alcohol in there. And then if I add that to, now I need another percent here. And now I'm adding that to the 15% alcohol, which is 15%, and I'll times that by Y. All right, so basically how we're kind of interpreting this is the concentration of the 15% alcohol can be found by the total number of liters times by its percent value. And then if you think about this logically, on this side you should also have a percent and you should also have a liters, right? So what kind of combined percentage do you need when you mix these two alcohols together here? Well, you need a 12.2. The question says you need a 12.2% mixture, right? So that's going to be 0.122. And how many liters do I need? Well, I need 100 of that. I need 100 liters. And that's how you can set up your second equation there, where 100 is the number of liters. Okay, great. Now, just like the previous question here, this is what I would do next. I would just simplify your second equation as 0.08x plus 0.15y. And then with a calculator, I would just do 100 times 0.122, and that gives me 12.2. So this is your second equation now. And I'll erase all that. Okay, now going back to your first equation, let me box this. And let me highlight this 0.08. So I will now solve this problem by using elimination, and I need a 0.08 as a leading coefficient on my x variable. So I'm going to take my first equation in the green box, and I'm going to multiply everything by 0.08. So 0.08 times x is 0.08x, and 0.08 times y would be 0.08y. And then finally, 0.08 times 100 is going to give me a value of 8. And there it is. There is my system there, and I can solve this using elimination. And I can eliminate the variables by subtracting. So I've done this a few times now. That and that will cancel off. So if I have 15 minus 8, so 0.15 minus 0.08, similar to like 15 minus 8, that gives you 7. So 0.07 is a decimal. Y equals 2. And now you can do 12.2 minus 8. So 12.2 minus 8 is going to be 4.2. And then finally, you can solve this now by dividing both sides of the equation by 0.7. So 0.07. Those will cancel off. and y would equal to roughly, is that 60? Yeah, that should be 60 liters. So you need 60 liters of y. Now remember, y was the 15% alcohol, and since you have a 100 liter mix, right? So x plus y is 100. We know y is 60, so that means x has to be 40, right? So then x equals to 40 liters. And that's how you solve that particular problem there. So I thought 11 and 12, similar ideas where you're combining two different units together. So make sure that the units match up, and then you're using the elimination technique. Okay, let's go on to a few more of these physics problems here. All right, let's take a look at question number 15. For question number 15, if I can blow this up a little bit, I have a plane that travels 2,835 kilometers in 7 hours with a tailwind, but only 1,827 kilometers with a headwind in the same time. Find the speed of the plane and the speed of the wind. Okay, so before we start labeling or setting up equations in this problem, I've drawn out two scenarios right here. Scenario number one in this orange little box right here, what I'm trying to describe in scenario number one is that the plane is going to the right, but you also have the wind right here in blue. The wind is also going to the right. So the plane is going to the right and the wind is going to the right. So if you think about that, the plane should be going a little bit faster because it's going in the same direction of the wind. Okay, so that's called the tailwind situation, right? When the actual plane is getting faster because it's traveling in the same direction as the wind. Now, in my second scenario, in this purple box here, scenario number two, the plane is still going to the right in blue, but now the wind is going in the opposite direction. So if the plane is going to the right, but the wind is going in its opposite direction to the left, the plane is actually going slower because it's fighting against the wind. That right there is called the headwind situation, right? So we have to be familiar with those two scenarios before we do this problem. Now, in diagram 1 and 2, you see I've labeled x and y just represents the speed of the plane. X is the speed of the plane, and y is the speed of the wind. In scenario number 1, if I get out an orange marker here, in scenario number 1, because the plane, so I'm talking about this case right here. Basically in this problem, if I label it correctly, we are traveling a total distance of 2,835 kilometers for the plane, and we're finished this in 7 hours. Okay, so using scenario number 1. Let me set the equation first for scenario number 1. X and y represent the speeds, right? The speed of the plane and the speed of the wind. Okay, so the total speed of scenario number 1 is really x plus y, because the plane and the wind are going the same direction. Now, in order to set up the equation, in physics class, speed is really your distance over time. Speed is distance over time. So I know my speed is x plus y, so my equation should be x plus y is my speed. Now ask yourself, what is the distance? Well, the distance in case number 1 is 2,835. So that's going to be 2,835. And what is the time? Well, the time is going to be 7 hours. So I divide this by 7. So this right here is my first equation. X plus y equals to 2,835 divided by 7. And if you want to set your second equation, it's going to be very similar. It's going to be speed is distance over time for the second scenario. Okay, so let me go ahead and set that equation now. I know I need to erase all this. Now, if I take a look at my second scenario in this purple box here, hopefully you'll see that the speed is a little bit slower, right? Because the plane is going in the opposite direction. So it's the speed of the plane minus the speed of the wind. Okay. And then the distance for that particular case, as the question tells you, is 1,827 kilometers. 1,827 kilometers. And this is also done in the same time, which is 7 hours. So the time is going to be 7 hours. So once again, using the formula that speed is distance over time, if I use this little physics formula here, the speed is now x minus y. The distance is 1,827, and the time is 7. So there you go. Those are my two equations, and these are the two equations that I'll be using to kind of finish off the rest of the problem here. I do apologize for the sloppy writing, so I'll do my very best to clean it up over here. For my first equation, I have x plus y, and I would go ahead and do this in your calculator, but 2,835 divided by 7 is going to be 405. So there you go. This equation is now officially done. And using equation number 2, this is the same thing as x minus y equals to 1827 divided by 7 is going to be 261. And there you go. Here's a much cleaner system equations here where I can solve. And I can solve this now by simply adding the two equations. So if I do x plus x, that's going to be 2x. And the y's will cancel off. And if I have 405 plus 261, 405 plus 261, that's going to be 666. And I can divide both sides by 2. And x would equal to 666 divided by 2, which is 333 kilometers per hour, I believe. So the speed of the plane is 333 kilometers per hour. So that's the speed of the plane. And then I guess you also have to find the speed of the wind. Okay, so let's go ahead and find the speed of the wind now. And I guess I can go back to this equation right here. We know that x plus y is 405. I know x here is 333. And we can now go ahead and find the speed of the wind. And the speed of the wind should be smaller than the speed of the plane, right? So when a plane is actually flying, if the speed of the wind is too great, then the plane wouldn't be able to fly, right? So the speed of the wind has to be smaller than the speed of the plane. So the speed of the wind is 72 kilometers per hour. All right, so that was a great question. It's a nice physics application, and there are some elements of using the elimination method to find the speed of the wind and the speed of the plane. Okay, let's move on to the final word problem in this homework guide here, and let's see if this one will be a little bit easier, but let's just see. A boat took 4 hours to make a downstream trip with a 6 kilometer per hour current. And the return trip against the current took 5 hours. What distance did the boat travel in one direction? Okay. So I've kind of drawn out two diagrams here, and one diagram is when this boat in yellow, this boat is now going down, and also the current is also going down. So the boat and the current are going in the same direction. So if you think about that, the boat should be going faster in the downstream direction. In the upstream direction, what's happening is the boat is now kind of going up, but the current is still going down. So if you think about it, the speed of the boat should be slower in the upstream situation compared to the downstream. So x represents the speed of the boat, and y is the speed of the current. All right, so let's go ahead and see if we can put together some equations for this particular problem as well. So if I take a look at scenario 1, which is the downstream case, I agree. I look at this, I see that x and y are going in the same direction, right? So the speed is x plus y. So my speed is x plus y. So x is the speed of the boat, and y is the speed of the current. And I know that the time here, I think the question says the time, it took 4 hours, right? So it took 4 hours to go in the downstream direction. Okay, and now if I take a look at the speed in my second direction, I notice that x is going up and y is going down. So the speeds are going in opposite direction. Now what about the time? This time it takes 5 hours, right? It takes 5 hours to go upstream, so the time is 5 hours. Now, one more piece of advice that I want to give you here is the question literally tells you that the speed of the current is 6 kilometers per hour. The speed of the current. Now, what letter represents my current? Is it x or y? Well, y is my current, right? X is the boat, so y is the current. So anytime you see a y here now, Sorry, let me get a little space here. Anytime you see a y like here and here, that has a value of 6. So instead of writing y, I can now write the number 6. 6 there and 6 there. And remember, how do I find an expression for my distance? Now, in order to do this, we mentioned that speed is distance over time, but distance is the same thing as speed times time. So distance is speed times time. So in order to find my distance equation here, my distance is going to be speed times time. And what's my speed? My speed here is x plus 6. So this is going to be x plus 6. And what's my time? My time is 4. So there is my distance equation right there. If I do the same thing over on the right hand side, distance is my speed. Now what's my speed here? My speed is x minus 6, right? So my speed is x minus 6. And what's my time? My time is 5. And that right there is my second equation there. So this one I'm probably not going to use elimination here. I'm probably just going to use substitution here. So here's a d, and this d equals to that d right there. So if I use substitution here, I can write down my, sorry, I'll put this in green here so the colors match up. So this would be x plus 6 times 4 equals to x minus 6 times by 5. So what I'm really doing is I'm making my distances equal to each other, right? So I'm making these two distances in purple equal to each other. All right, after that we can just solve this now. So distribute all that, so that's 4x plus 24 equals to 5x minus 30. And then from here, you just use your solving equation techniques here to solve this. X is going to equal to, I believe it's going to be what, 54 here? Yeah, so x equals to 54. And then from there, you can also solve for d by plugging in the 54 over there, right? And that should be able to solve for your d value, and that should really conclude this problem here. I don't know if I have time to solve for my distance here, but let's see if I can do it quickly here. So it'll be 54 plus 6. And times it by 4. And if you do that, I believe that's 240 kilometers. Okay, so that concludes this homework video guide.